Hello, everyone, and welcome to a new Stylus Pro series workshop. Today we're going to present a workshop. This is a series of 3 workshops. Today is the first one. Tomorrow we'll have another one, and Thursday will be the third one. Okay, we're going to talk about Stylus. We'll start with the basics today. We're going to talk about tooling tomorrow, and then we'll finish with some advanced examples on Thursday, okay? But first of all, I'd like to introduce ourselves. My name is Jose Franco. Here with me is my colleague Crisco. We are both integration engineers at Off-Chain Labs. Off-Chain Labs are the service providers for the Arbitrum Foundation and are the initial developers of Arbitrum 1 and Arbitrum Nova before they were transferred to the DAO. Off-Chain Labs are also the developers of Arbitrum Orbit and Stylus, which is what we're going to talk about today. If you don't know what any of these mean, we invite you to go to our Discord server, and then, we'll be more than happy to answer your questions there, okay? All right, so today, what are we going to see today? We're going to start with what is Stylus. Stylus. We're going to explain a bit what it is and why does it exist. Then we'll do a brief introduction to Rust, and we'll talk about the Stylus Rust SDK. So we're going to talk about Rust because it's one of the first languages that we are focusing on for creating tools to write smart contracts, okay? This brief introduction is going to be like, we'll just cover the basics in case there is someone who doesn't know a lot of Rust, so they'll be able to understand what we're going to see. Then we'll talk about the CLI tool for Stylus, which is called Cargo Stylus, and then we'll show you how to run a local DevNet and some Rust contract examples. All right, so what is a Stylus? Stylus is an upgrade to the traditional development environment for smart contracts on EVM chains, okay? What this means is that before Stylus, if you wanted to write a smart contract, you will probably do it in Solidity or in Viper, but those were your options, right? Arbitrum Stylus allows you to write smart contracts in other languages like Rust, C, C++, and more languages. And this is possible thanks to a second virtual machine that runs alongside the EVM and that executes WASM programs, okay? Both virtual machines are fully interoperable. That means that contracts that are written in Rust, for example, can interact with contracts written in Solidity and the other way around. So one of the main benefits of Stylus is that it allows us to access new developer ecosystems. If you are a developer of Rust, for example, and you want to write a smart contract, you don't need to learn Solidity anymore. You can write them in Rust. So essentially, we are also bringing this the blockchain ecosystem to these developers, right? Another benefit of Stylus is that it increases speed and reduces cost, and this is because generally WASM programs are more efficient than their counterparts in Solidity, okay? And not only that, but memory usage is also improved, and it opens the possibility of new use cases or to develop these use cases like advanced cryptography or generative art, among others. So we are currently focusing on an SDK for writing smart contracts in Rust, and we have also some proof of concepts. Well, they are fully functional, but smaller SDKs for C and C++. But actually, today, any language that can be compiled to WASM can use Arbitrum Stylus, and we have examples of smart contracts written in SIG and AssemblyScript, in case you want to take a look. And Stylus is just a reminder that the Stylus is now available in all Arbitrum chains, Arbitrum 1, Nova, and testnet Sepolia. So how do you get started with Stylus? Well, being here today, that's a great first step. But then we have 3 resources that I like to give when people ask me how to start writing smart contracts in Rust. The first one is the Quick Start. That's a page in our documentation portal, in Arbitrum's documentation portal, that goes through how to set up your environment and work with a counter contract, which is written in Rust. Then there is another page in that same documentation portal, run a local dev node, that shows you how to run a node in your machine that you can use to test your smart contracts. We are going to take a look at that later today. And then Stylus by example. Stylus by example tries to mimic Solidity by example, for those who know that portal. So you'll find there examples of code, snippets of code, and explanations of things you can do with the Stylus Rust SDK. Okay, there is also some example contracts that you can take a look at, and yeah, it's a great resource to know what to expect from the SDK. All right, so let's do a brief introduction to Rust. Now, this is not meant to be a comprehensive guide to start writing programs in Rust, but we are just going to cover the basics, so we'll be able to understand the examples that we'll see later today and tomorrow and on Thursday, okay? So for those who don't know Rust, here are a few characteristics of the language. It is a general purpose programming language. It is strongly typed. It has a helpful compiler. This means that it is designed in a way that potential issues will mostly arise at compile time, the ones that can arise at compile time, obviously, instead of letting them go to runtime. It implements zero code abstractions, powerful pattern matching, and it's fast. It's very fast. Okay, so let's take a look at some of the basics of the language. And let's start with variables. Now, one thing about Rust is that variables by default are immutable. That means that, you see the first example here, if you declare a variable like let x equals 5, and then you change the value of that variable, that's not going to compile. But instead, if you want to make a variable mutable, then you use the let mute declaration for the variable, and then the compiler will allow you to change the value. Okay. For data types, we have the regular ones, or Rust has the regular ones, unsigned integers, signed integers. Here are some ways to define an integer, like using decimal, binary, hexadecimal, byte. There is also booleans, characters, tuples, which are groups of variables that might have different type, each of them, and then arrays that have all of the elements have the same type. And then we have functions. Functions are declared using fn followed by the function name, and we use the snake case syntax for names. This is true for function names and for variable names. Okay, snake case is what's usually used in Rust. Parameters in functions are defined with the name colon type syntax. We can see here the second example, this function +1. We are receiving a parameter called x, which is of type i32. And then we use the arrow syntax to define the return type. In that same example, i32 is the type that is returned. And now for returning a value after the function has executed, we have two ways of returning. So if the final statement of the function doesn't have a semicolon and doesn't need to have the return instruction, like this one that we have here, +1, that's considered a return statement. So the function will return that x +1, okay? If you want to return before reaching the end of the function, you can also use the return syntax, the return whatever, and semicolon syntax, okay? Now, structs. For those who are familiar with object-oriented programming languages, structs are similar to objects, okay? They are not exactly the same, but they are similar. They define a group of data with named fields. In this example, we can see a struct called rectangle, which has two fields, width and height. And we define a method in the second part of the example using the impl instruction, impl rectangle, and then we define the function area within that block, okay? This is an example also of how we create a new variable. In this case, we just use rectangle, the type of the name of the struct, and then pass the fields, the value for the fields that we want. Enums. Enums, as always, allow you to define a type by enumerating different variants, right? And that's how you define an enum. This one is called coin, and the different variants are penny, nickel, diamond, quarter. And below, you can see how you can reference these enums: coin, colon, colon, penny, coin, colon, colon, nickel, and so on. There are different control flows structures as well. We have match here, which is similar to a switch case in other languages. Then we have an if block, an if expression. There is also loops, whiles, fors. And then we have traits. Again, for those who know object-oriented programming languages, traits are similar to interfaces, okay? They define what's the expected behavior of a certain type, right? So the example that we see here, this trait called summary, expects that whatever type is implementing that trait has a function called summarize that returns a string, okay? And both structs and enums can implement traits. So following the example from before, we have here a struct called tweet that implements the summary trait, and it has a function called summarize there, which returns a string. Okay, macros. Macros are, they are a way of writing code that writes other code. Okay, this is fun. So they are similar to functions, but functions return a value. In this case, macros generate code, okay? And this happens during compile time. So what happens here is that you can abstract away certain parts of whatever framework you are building. So you make it easier for developers to use the framework that you're using, that you're building, okay? In this case, the Stylus SDK uses macros to abstract away a lot of the complexities of dealing with the Stylus virtual machine, okay? And we see here a few examples of macros: println, derive, and vec. All right, if you want more information about Rust, the Rust book is a great resource for both learning and as a reference guide. If you don't remember how to do something, the Rust book is very well divided into different meaningful sections, so you can find whatever you need there. Okay, and here's a second poll that we want to do as well. The question is, what blockchain tools do you frequently use? So I think my colleagues are going to paste the links to that poll in the comment section here. I'll give you guys like a minute or so. And yeah, also in this slide, we can see towards the end the Telegram channel that we have for Arbitrum Stylus. There are many Stylus developers there, so you can ask questions there as well. There is also a specific channel for Stylus on Discord. So in case you are building something and, I don't know, you're stuck on an error or trying to debug something or something like that, you can go to either Telegram or Discord and post your question there, and we will all try to help you, okay? I'm just going to give you like 10 more seconds and I'll continue. All right. Let's continue with the Stylus Rust SDK. Now that we know the basics of Rust, let's see what the Rust SDK, what the Stylus SDK offers. Now, this is the tool to use for writing smart contracts in Rust for Stylus. So it is built in a way that provides simple, familiar design paradigms similar to Solidity. Okay, it makes use of Alloy, which is a powerful primitives library that has built-in Solidity type conversions. We're going to talk about this a bit later, but in any case, in the end, we are using we want to be compatible with Solidity, so we somehow need to be able to use or to access the same types as Solidity. So Alloy is the perfect library to support that and to help the Stylus SDK do that. Okay, and because it is written in Rust, it allows you to access powerful Rust features while remaining composable with Solidity smart contracts. Okay, so you are going to see three different types of variables when writing smart contracts, okay, with the Stylus SDK. The first one are local variables. These are variables that are defined within a function, are the regular variables that you are used to work with if you've used Rust before. Then we have state variables. These are the variables that are going to store information on chain. Okay, they will make up the storage of the contract on chain. And then we have global variables. For those who are familiar with Solidity, you know about these. They are variables that are available from the virtual machine and that you can use during execution of the smart contract. These are message sender, message value, block timestamp, block number, those. So one of the important things to keep in mind here is that storage in Stylus contracts mimic that of the EVM, right? So the primitive types that we use for storage variables must be compatible, okay? And this is where Alloy primitives help us a lot because they have these primitive types. They allow us to be compatible with Solidity. Okay, so for example, you can see here these U8 and U256 types that we are using. These are the primitives types that come with Alloy. All right, so what things do we need to keep in mind when writing a smart contract? Okay, in Rust using the Stylus SDK. Well, there are many things, right? But if we go to the basics, we want to be able to handle the storage and to handle private and especially public functions, okay? So for the storage, what we do is that we define a number of variables that will be our state variables. Those are the state variables that we mentioned before, okay? And they as I said before, they'll make up the state of the contract at any given time, okay? So the way we do this is that we have this storage macro that annotates a struct that is intended to be used for storage. Okay, so we'll have a struct there annotated with storage. It will have several fields, and each one of those fields will be one of the state variables. Okay, and then we use the entry point macro to define that struct as the root struct. We are telling Stylus here that the execution of the contract starts there in that struct. Okay, so here is one example. We have a struct called contract. It has both macros, the storage and entry point. And then we have three fields within that struct, okay? We have three state variables for this contract. We have initialized, owner, and max supply. And notice also that we're using special storage types here: storage pool, storage address, and storage U256, because in the end we are going to access storage. So we want to be able to handle those writing and reading operations. All right. So how do we define then the contract methods? We've talked about storage, so let's talk about the contract methods. So the way we add methods to our contract is that we add an impl block for the struct that defines the storage layout that we just saw. And then we add the functions within that impl, okay? Private methods, well, they are only going to be called within the contract, and public methods are going to be publicly called from outside of the contract, right? And so for private methods, we don't need to do anything, but for public methods, we need to annotate those with the public macro, okay? What we're going to do is annotate the impl block that contains all the public functions of our contract. We can see here an example. This will be a different contract that the one we saw before. This is a contract called counter. There will be a struct counter above this part of the code, right? So then we add an impl block for that counter, and then we add, in this case, one public function, which is number, and which probably just returns the state variable of the contract. If you want more information about the Stylus SDK, Stylus, by example, is one of the best resources that we have worked on right now. There are a lot of examples there, a lot of explanations of different things that you can do, or how you can handle different things. And yeah, so All right, so let's finish this part with Cargo Stylus. Cargo Stylus is the CLI tool that we use for Stylus. Okay, it's the tool that we use to perform operations on contracts, on Stylus contracts. We're just going to see the basic commands here, but basically, if you want to create a new Stylus project, you use Cargo Stylus new and the name of the project. This is very similar to how you do it with Cargo Rust. You just do Cargo new. In this case, you do Cargo Stylus new, and this is going to create one new folder with a template of and some code that you can start tweaking, changing, and writing and updating for your smart contract. Then we use Cargo Stylus check to verify that the contract can be compiled and that it meets the on-chain requirements of Stylus. Okay, so once your contract has been built, you run Cargo Stylus check, it compiles everything to WASM, and then checks that it is compatible with Stylus or not. If it is not compatible, it will tell you why. Then you can deploy your contract with Cargo Stylus deploy, and then you can export the ABI of your contract with Cargo Stylus export ABI. All right. Okay, now I'll pass it to Crisco, who's going to talk about how to run a local DevNet, and he will show you some examples.
Thank you, Jose. Appreciate that. Let me get my screen shared. All right. Should be. Let's see. Is that going okay? Is that showing yet?
I think it's not. Not sure if. Let me remove mine to see if yours show up.
Do you? Yeah. Do you see it in the stage? Oh, there we go. There we go. Okay, perfect. Okay, cool. All right. Great. So, like as Jose was just mentioning, we've got. He was mentioning the cargo stylus CLI tool. I'm sorry, my autocomplete's like trying to fill in. So it's trying to fill in to assume what I'm about to type. But as Jose mentioned, with the once you've installed Cargo Stylus, you can initialize new projects just by in your CLI typing Cargo Stylus new, and you can just call it counter. I'll call it counter demo 2. And what that's going to do is that's just going to pull in all the dependencies, and it's going to go ahead and install a new example in that counter demo 2 folder. And if we go there and we ls to show you, it's got all the files there. It's that you need, but I've got a better demo already set up here at counter demo, so I'm going to cd back into that. But you can go in and edit the source and go into the librs file to edit it, which I'll show you what that should look like right here. And this is more or less what you'll see when you do clone a new project. You're going to start with, I'll start just by explaining from the top right here. This is sort of like just like a memory allocator for Rust. All you need to do is just include this. You don't need to think much more about it beyond that. But there are some like boilerplate lines that you just need to have in every contract. So you need an allocator, and you just got to export that. And this line right here has to do with exporting the ABI for producing like JSON ABI outputs for the Solidity like ABI interface that your contract complies with. So again, these lines don't need to be edited. Just keep them like that. Over here, we've got our dependencies, which include the Alloy Primitives library that that Jose was mentioning. With the we're currently just using 256-bit integers from that. I've also pulled in a console a console feature that we have within the Stylus SDK that allows you to output text to your local dev node. So once you've got your local dev node, if you run this contract in debug mode, you can output variables to the screen to kind of debug locally. And I'll show you how that works in a little bit. And this just sort of like includes a lot of common, this prelude feature just includes a lot of like common traits, macros, things like that. So you don't have to like import every little feature from the SDK. This includes a lot of things just as sort of a one-line thing, including like the entry point macro that again Jose was mentioning earlier. So as we mentioned, the entry point or the beginning of every contract, every Stylus contract that's written in Rust is typically this entry point struct. And you'll notice this syntax. There's actually two different ways that we support to define these storage structs. One is using Solidity style syntax, and this uses the sol storage macro. So you use sol underscore storage with this exclamation point. And then within this block here, you can define a struct using Solidity syntax instead of Rust syntax. So this is like equivalent to, equivalent to Solidity here. So I can just sort of say my address here, and that's just going to work because we're using this sol storage macro, and I'm using Solidity so you can just, if you're working.
Hey, Chris, I think your sound got off for a minute there. Yeah, no, we can't. Yeah, we can't hear you. Okay, it looks like Chris is having some technical issues, and he's gonna be back soon. All right. I laugh because these things always happen when we are streaming live.
I know this sometimes is happening, but thank you everyone for waiting. Maybe right now you can go to the poll and help us with your insights here for sure. And yeah, also I recommend you to join the Stylus Devs Telegram group. You can ask all the questions around the Stylus here. The team is super supportive, so people will help you out. And yeah, maybe we can share an alpha. Well, basically, right now, till till we're waiting for Crisco, there are 2 hackathons happening online at the moment. I'm going to share the links with you. Um, And as well, we are going to be in DEF CON. This, DEF CON is the one of the most important Web3 events that are happening, and also the biggest one for the Ethereum community. The Ethereum Foundation is organizing that one. So during that week, we are going to be participating in. We are going to have side events for sure. We are going to be participating in the main event as well, with our amazing speakers, and as well, we are participating in the ETH Global Hackathon. So yeah, this is a great place for you to shine as well. We have a really nice comment from Future Trees. Looks like Stylus has improved a ton since December. What do you have to say about this, Jose? Do you think that as well?
Oh yeah, of course. Yeah, sure. And yeah, we are still like it still has a lot of room for improvement, especially the SDK. Well, that's the our main focus right now, the Rust SDK. And yeah, as Future Trees exactly as Future Trees says, it has improved a lot since the last few months, and there is already we already have internally a roadmap of work of improvements that we want to add there as well. And actually, I just wanted to mention, if you guys have any questions about what we've been presenting until now, just feel free to add a comment to the chat, and yeah, I'll take a look and answer you guys.
Yeah, as all the questions you have, and yeah, some saying hi to Ralston. Matt Hamilton is saying hi as well. Thank you, Mr. Oscar. Super cool to see you here. Franco La Rosa too. Well, yeah, we have a question from Future Trees. What do you think of on-chain vector stores with Stylus? That's a good question.
Yeah, and it's a bit complex for my current knowledge. So, but what I would do is to post that question either on Telegram or on Discord, and so we can. I mean, I can ask internally about this, but if you post on Discord on Telegram, we can follow up on that better actually than just this chat. Okay.
Yeah, thank you, Future Trees, for your question. And yeah, we have, seems like Chris is having some technical issues. I'm sending Chris another invite for the live stream. Just give me one sec. Cool. But yeah, I'm going to share with you all the other the hackathons that are happening right now online. Actually, the first day is today for both of them. These are organized by different communities or projects. One of them is organized by Erendao. They got a grant from the Arbitrum DAO, the Questbook team, and yeah, I'm going to share the details with you now for you to participate if you want. There are some prizes for you that you can participate for. I'm actually I'm going to share my screen. Just give me one sec. For you to see everything. All right. So this is the Erendao. Can you see my screen, I believe? Let me bring it. You can see it, Jose? I believe so, right?
Yeah, we can. Yeah.
Super. So yeah, this is the Erendao team that is organizing this virtual hackathon. If you want to check it out and participate, it's going to be super cool. Today is the first day, if I'm not mistaken. No, yeah, it's today. So you can see that one. And there is another one happening today that is actually is a woman hackathon that is organized by Botun and Crypto Conexion. Here is this one is online as well and is starting today. Yeah, it's a woman Web3 hackathon. So yeah, you should participate now. And you can even start using Stylus. So yeah, seems like Chris is back. Amazing. So thank you everyone for listening to this hackathons information. So yeah, we are back with the coding session with Chris, Stylus session. Thank you.
Sorry about that. Where did it cut off, Jose?
I'm not really sure.
Okay.
What was the last part that you were? It cut off like around 1 minute, a minute and a half before you went.
Okay.
Before you
All right.
realized you didn't have sound.
Okay, cool. All right. Cool. Then I'll just kind of reiterate the previous minute. Okay, cool. All right, so it's just kind of going over, right, the explanation of like how this and this are two different ways of writing the same thing. So basically, like every this is gonna, let me comment this out. This that should go away. Okay, so this syntax up here, which is the default that when you install like the counter example using Cargo Stylus new, it's going to use that like Solidity style syntax for defining the storage struct. However, if you just want to use pure Rust, you can do that here. You just use since this is outside of this macro context that we created up here. This is just using pure Rust. So we're referencing this U256 type that we pull in from the Stylus SDK up here, instead of using like a uint 256, which is actually like Solidity style syntax for declaring a 256-bit integer. Just something to know. If you just want to code in pure Rust, you're welcome to do that. You don't have to use that Solidity style, but it is important. Like the reason why we have alloy in these special types is because we want the way the EVM stores, the Stylus uses the EVM for storage, so we still have to store everything in a EVM compatible way, even though we're getting access to a totally different VM environment and we're running in a WASM context. We still have to store things in the same space that Solidity contracts kind of use for their storage. So we have to store everything in terms of 32 bytes or 256 bits. So it helps to have this like this Solidity compatibility, because a lot of things need to store in these types of sizes anyways. And when your contract's being called from other contracts, it's usually going to be like a Solidity contract that might be calling into your Rust contract, or vice versa. So it's helpful to use that Solidity ABI for both for your storage types and for your output types on your functions. It is important to note you don't necessarily need to follow those. I mean, we provide these as built-ins. However, you would need to implement like a special storage type if one didn't already exist for that type. But by all means, you can do storage U64. You just need 64 bits or whatever you might need. Going back down into the impl block that, again, Jose was covering earlier, we use this public we're providing impls for the counter struct. I'm back, right? I think I blinked out for a second. Yeah, I'm back though, right? Okay, cool. Just want to confirm. All right, the everything within this impl is going to be a public method. If we want to define private methods, we just create like a separate impl here, and we could just say fun simple method here, and we're going to have like a reference to self here, and let's say we just want to return a yeah, we'll just return a U256, stick with that. And we want to say self or U256 from 1, 2, 3. And that's just going to be a, oh yeah, remove the semicolon there. Yeah. And so right now it's warning me because it's never used. I have a lot of like warnings turned on in my VS Code that kind of warn me that this is dead code. So I could, Rust is very particular about, it'll warn you if you try to define a variable that isn't being used anywhere or a function that isn't being used anywhere. So it's just warning us there. The typical thing to do in Rust, if you're not going to use something, is to prefix it with an underscore, and then the warnings go away. That's one way to deal with that. Another way would be to just like kind of use this. So if we want to reference that number, we could do that here. We could return the self dot simple method value here, and basically when this function gets called, every time it's just going to turn the number 1, 2, 3 instead of the value of the count up here. It's actually, you know what, let's change this to be a count, and then let's remove this. I'm going to go ahead and demo the counter real quick so that we get more context with how this works. So yeah, I changed everything here. So self.count, self.count, and current. Let's call this current count, and self.count, and current count. Okay. Okay. All right. So we've got, just to kind of start from the top, we've got this this number method right here, which is just going to return the current count of the counter. And then if we want to set it to a specific number, we can pass in a number to this method and set that number on the storage, on that storage count up there. And then if we just want to increment it by 1, we can call this increment method. So to actually like invoke these functions, we have to use the CLI to do so. So over here on the left, like in my terminal, I'm running a local dev node for Nitro. And if you go to like, while you're working on Stylus contracts or code, Jose mentioned Stylus by Example earlier, which is at stylusbyexample.org. But there's also like great resources at docs.arbitrum.io. And so when you click like write Stylus contracts, this is kind of like providing additional context and SDK information and things like that. But one thing you want to do is reference to work locally is you want to click this run a Stylus dev node down here in this section. And then that's going to explain how to run like a local development node where you don't have to like necessarily hit the Sepolia testnet with your examples. You could just code locally and deploy locally, and it has like testnet ETH and everything you need. So I'm running that node here, and once you've cloned it here, you just run .testnode bash init, and it'll run just like this. It does take a few minutes, so I'm not going to rerun that right now. But that's what that looks like. Okay, going back to here, just to show, we're going to also use a tool called Cast, which is from Foundry. And if we go right back here to, I think it's get foundry.sh. And right here, this is going to explain like how to install Foundry on your local system. And then if you click book, that's the docs for Foundry, and that explains like how to use this tool that I'm about to use, which is called Cast. And Cast is just a very convenient tool, whether you're using Solidity or Rust, to be able to interact with smart contracts. And you know, you can just kind of iterate through this, and like it'll show you how to call methods and how to send transactions to the blockchain itself. Okay. So to actually show that in practice, we're going to go ahead and cast call. And assuming you've already installed Cast, we're going to pass in the RPC URL just like that. And then because I'm running the chain locally here over here on the left, it's running on localhost at port 8457. So that's just the default port that we use to run Nitro, and that is going to be the RPC that you use to call contracts and to to send transactions. Okay, so the next parameter here, whenever I'm calling, that's not using gas because that's just a read-only function. So there's no need to pass in like a private key here in order to send this call, because it's a read-only function that we're going to invoke. So the next this next parameter here is just the location of the deployed contract. And then when I go over here, down here, this number syntax right here, this in the quotes, basically I'm telling Cast how to interpret the bytes that it gets back from that contract, because when by default it's just going to return these raw bytes. So we need to kind of tell it the shape and the structure of the function that we're calling, and we use Solidity style syntax again for this type of thing. So we're calling this what we're saying is we're going to call this number function, and that doesn't take any parameters, so it's just an empty parentheses. And then this return, the second set of parentheses, is saying we're expecting a single UART256 value to be returned from that function. And so when we call this, it should return 0, yeah, because the counter starts at 0. So when we there's another step that I did skip over, which is deploying the contract. If we type cargo stylus deploy, you'll kind of see like how that works, how that looks in practice. Again, with this one, we do have to pass in a private key. And this private key that I'm showing here is coming from, this is just when you run a local node, it's going to provide a dev account right here, and this is the address for that account, and this is the private key. So again, from our docs, you can find all this in the run a local dev node section, and here down here in default endpoints addresses, it'll show that dev account or pre-funded ETH. So you can test locally. You don't need Sequoia ETH or whatever. You can just test locally on your own system at this public address. And so most of the transactions you're going to do, you'll just use this public address and then this private key here. This is a publicly known private key. So yeah, it's just for development purposes only. But yeah, when you're deploying locally, you'll just kind of use that private key there. So when I go back here, that's what I'm doing here. I'm deploying, and I said no verify here because with this no verify flag, I'm basically saying we're not going to be publishing this to Etherscan or Arbitrum, where we need to verify the contract source. So we can kind of skip some of the steps in the build process to make sure that the contract is verifiable. So yeah, and then this -e just means endpoint, and then private key. So that's how you deploy a contract. Yeah, but going back to the call again, if I call, it's at 0. If I want to actually send a transaction, that's going to be I'm going to have to use this cast send method. So I'm going to call cast send. I'm going to keep the RPC the same, okay? But I should now have to pass in the private key I should now have to pass in the private key to that. So let me copy that over real quick. Yeah, private key. Oh, sorry, need to find it. Okay, there we go. Okay. All right, so I've got my private key there, and I am calling the same contract address, and I need to go over here. Instead of calling number now, I'm going to call increment. I'm going to change this to increment, and there's no return value, so I'm going to remove this return value. And basically, there's no argument either because increment just increments by 1. And I should be able to just hit that, and it said success. Okay, cool. So we got a block hash. All the information that you would get from a live chain, all that's right there in the console. And so now when we call, if we call, sorry, this like things in my screen. Okay, cool. Now I can see it. Now if we go back up and resend this number call where we get the number for the counter, we can hit send, and now it shows 1. Okay, so that's kind of like just how you tend to develop locally in Stylus, but Cast is again useful for Solidity as well. So great tool to learn, and you can test against live on Ethereum mainnet or an Arbitrum or an Arbitrum mainnet. You could just like call and invoke public contracts all day long like that. So very useful skill to know. All right, so let's kind of like also. I want to real quick demo like this console feature that I showed earlier, because one of the nice things about the Stylus SDK and like and working locally is that you can kind of just like use the console like you might in web development, where you say hello world like this, and you can just sort of invoke a console method, and it will show in the this was like an earlier demo that I did where it says Stylus says yes it works, but I'll show you this hello world that I showed here. It will show over here in the terminal when you type that like console method. And so that's a super useful thing when you're debugging or you just want to see what something is, and intermediate thing. So it's there's just one little setting that you've got to change that when you work with this console function, and that is you need to go back here to your cargo toml file in your contract, which is at your root. This is part of Rust, where this is where you set up your dependencies for your smart contracts. And these include packages that are pulled in from the website that is at freights.io. So these are where like this is Rust public package repository. So whenever we're pulling in on our cargo toml, like just a library or whatever, that's coming from crates.io, and that includes the Stylus SDK, which we publish there, and the version number. So you set up your dependencies like it's very simple with this syntax like this. But if you want to use this console feature, the way to do that is to add this little debug feature flag, and that's going to set it up so that it will actually output locally this like Stylus says yada yada whenever you console output something. So going back to this, I'm gonna redeploy this example to show this new hello world string that I just did. So I just, again, cargo status deploy, and I'm just gonna skip over and redeploy this contract, showing you how this works in practice. So that quickly deployed something. This time it deployed at an address that ends in ED49. So usually I'll just kind of copy paste that address. And when I want to go back here to call this function, I'm gonna have to delete this contract value out right there. Instead, the new contract address that it got deployed to ends in ED49. So now when I hit call send, see how it says over here on the terminal screen on my left at the bottom, it says Stylus says hello world. So that what that did was it just output that function there. But I can also output values. So to output a value, I just create this, you just use this syntax here as a template, and then I can say, let me set a local, let's current count equals self.count.get, and that's the syntax for getting the current value from the counter. Now it should output current count. Let's just say current count here. And if I redeploy like this, it should redeploy to this address. And if I want to call that, I'm going to now change this address back to the newly deployed value. And then now it says, yeah, over here on the terminal, current count 0. And if I want to increment that call to show you that the count is actually working, I can say, oops, over here, send RPC, everything's good there. The contract address is correct, and instead of calling number, I'm just going to call it increment, and didn't do private key. That's right. Private key. Let me grab that again. You can set these to local variables, which makes it easier to work with. But just for brevity, real quick, we'll go back here to get this private key, and then paste that here. And then now when we call send, now when we call it to get that number, yeah, now it's showing the increment account. Okay, so one other quick example I'm going to show before I kind of wrap this up is just maybe like how to add something like an owner to this, just as a quick example for like, let's say we want to let anybody like increment this contract, but only like maybe we got something like the set number method that we only want an owner. That's kind of a typical pattern in uh, in Solidity, is to have an owner that can only reset this this count. So one way to do that, you can hard code. You could hard code an owner. So this is one strategy to do that, which would be the downside of this approach, but it would be that you can't change the owner per se. Would you could set like a constant value, and we can set it to that. We could set it to our if we go back over to Safari, we go back to running a local dev node. It's this is the dev account that we've got, and if we wanted to, we could set the owner to be this this address here that we've got, and to set the count, to reset the count, we could do this such that only this owner could invoke this contract. So let's do this. And actually, let's add what we'll do is we'll add an owner here that has a storage address to track we'll call this just the initial owner, and then assert overrides, no associated name. What is? Oh, is that from this? Yeah. Okay. So we'll track the owner with this storage address, and then we're going to create an init method. So we're gonna do fun init, and we're going to say mute self, and we're going to make it so that this method initially run this method, we can only this deployer address can invoke this. So if address parse, we're going to do parse check summed owner, initial owner. Yeah. So we're going to say, we're going to initialize that. Yeah. If, let's just do this. Let's do let owner address equal address part sum. So what we're doing here is we're parsing this string as an address, and then we're going to throw an error if it doesn't work. And this failed to resolve type, so we're going to pull that in from LA primitives. So we need that from up here. Hang on, sorry, we're going to pull in address. So we need the Alloy address type as well as the U256 type now that we're introducing address functionality. And then we're just gonna set self.owner to this owner address, and then that's going to self.owner.set. Yeah. So we're parsing this constant, the string constant that we're using as our initial owner, as the owner address. We're calling this. This is a alloy function that parses a string. Since we're using this constant that's kind of like embedded in the contract, we're parsing a string as an address, and so we also need to have a failure condition here, and throw an error if it doesn't work. And then we're going to go ahead and set the owner to that parsed owner address. So now that we have the actual alloy solidity address, we're able to set that in storage like that. And then when we now this method is, it can be called by anyone, but it's basically just going to initialize the owner address as that TDOE address. Seems like I can't write. Is there any questions or something? Future trees. If you want to make the deploy the owner and that init, you would just call message sender. Yeah, I mean, yeah, if you want to, well, see, the problem, I guess the problem with using message sender in the init is that anyone could call that init. And technically, you could get front run. Somebody else were to try to invoke that init method before you. This is one of the things that we're trying to work on to improve with Stylus is the constructor story, because Rust doesn't have constructors, and we're not able to really invoke like traditional constructor style methods inside Rust. So we've got a solution that's in the works for that, but right now you'll have to do something like this sort of pattern. You'll have to like initially gate the init method with a constant that guards this init method from really initializing it as anything else. It could be an env if you wanted an open source contract that is right. Well, it's still, no matter what you did, I guess, like, because storage always initialized to 0 values, right? And because you need some sort of way of knowing, who should be able to call a certain method or not, you'll kind of have to use embedded constants for now. And if you really want to gate that, if you want to avoid the case where you get front run, so that's the reason why you kind of have to do this pattern. You have to like hard code an address, gate this method so that it only sets it to that address, and then once you've got that, you can also add like a boolean that states whether the contract is initialized or not, that gates the other methods from being invoked. But this is just one pattern of dealing with the fact that the Rust contracts don't have constructors. But it is something that we've got like a better, can always, exactly. Yeah, you can use code generation to sort of automatically fill those values in. Absolutely. Yeah, very good call out. Okay, so that's just kind of one way to do that. And if I want to, I mean, I can kind of show that demo again, but I think we are kind of running sort of over on what we wanted to allocate for this. So I'm probably going to wrap it up there, but essentially that's what you would do is, then you could, within these methods, if you wanted to set, only allow this to be called, you could just basically say let current owner equals self.owner.get, and then if message sender does not equal current owner, or only if message.sender equals current owner, then you would only then allow the only then would you allow the count to be reset. And those parentheses are unnecessary because Rust doesn't care about that. And that error should go away. Yeah. So exactly. So basically, we're just only allowing the owner to set or reset the counter. So that's just like a quick example of how to do that kind of pattern in Rust. Yeah, and that's just kind of to get your journey started. But as Jose was mentioning, Stylus by example.org. If you go to that stylus-by-example.org, you can click through these sort of examples that kind of go into, how to use the console, all the different primitive data types that are available, and how to parse those from into strings or vice versa. All external contracts, how to send ether, all the way to like full application examples of how to do ERC20, ERC721s, English auctions, multi-sigs, etc. There's just a ton of code examples there. And again, as mentioned, you also want to also reference docs.arbitrum.io for more in-depth kind of SDK reference. You can kind of see, some of those things there. So just kind of goes through that. But yeah, just wanted to cover that for this one. Also, yeah, like as I think we're sharing links to t.me/arbitrum_ I think it's Arbitrum Stylus devs on I think we've got the link for the Telegram chat, but we've got like Arbitrum Stylus. I can't drop text in the chat right now, but if somebody can drop that link to the Telegram group, we've got a Telegram group that there's lots of other Stylus and Rust devs in there, people from our team as well as Open Zeppelin and a couple others that are happy to help out if you've got some questions. So yeah, we're going to continue this series tomorrow. Jose, do you want to add anything before we wrap up?
No, nothing else. I was just discussing internally if we wanted to show something else or not, but yeah, that's it. We can continue tomorrow with the next workshop.
Okay.
Thank you very much. Yeah.
Excellent. Thank you all for tuning in. Appreciate your time, and we'll see you all tomorrow.
Thank you, everyone.